The laws of motion. Learning about the different laws of motion by Newton's principle of conservation of momentum. Newton's second law of motion. Mass or velocity alone is not responsible to produce the effect of force. There appears to exist some property that combines the mass and velocity of the object. Newton introduced this property as momentum. Momentum. The total quantity of motion contained in the same body is called momentum. Mathematically, it is measured as the product of mass of body and its velocity. P is equal to mv. Momentum has both magnitude and direction. Its direction is the same as that of velocity. SI unit for momentum is kilogram meter per second and CGS unit is gram centimeter per second. As velocity of an object changes due to application of force on it, the force also produces change in momentum. The force necessary to change the momentum of an object depends upon the rate at which momentum changes. Newton's second law explains about change in momentum. The rate of change of momentum is directly proportional to the impressed force and takes place in the direction in which the force acts. Let a body of mass m moving with velocity u be subjected to force F acting in the direction of motion. Suppose v is velocity of body after time t. The total initial momentum of a body is mu and final momentum is mv after time t. So, rate of change of momentum is equal to change in momentum upon time. That is mv minus mu upon t. We take m common from the equation and we get m into bracket v minus u upon t. That is ma. Hence, by Newton's second law of motion, rate of change of momentum is directly proportional to F. ma is directly proportional to F. F is equal to kma, where k is equal to 1 and a. In SI system, Newton is unit of force. 1 Newton is the force which causes a mass of 1 kg to move with an acceleration of 1 meter per second square is called 1 Newton force. 1 Newton is equal to 1 kg into 1 meter per second square. In CGS system, dyne is unit of force. 1 dyne is the force which causes a mass of 1 gram to move with an acceleration of 1 centimeter per second square is called 1 dyne force. So 1 dyne is equal to 1 gram into 1 centimeter per second square. In a high jump athletic event, the athletes are made to fall on a sand bed. This is to increase the time of the athlete's fall after making the jump. Why? In a high jump athletic event, the athletes are made to fall on a sand bed. As the sand is loose, it slides when an athlete falls on it. This increases the time taken by the athlete to move to rest on making a jump. Therefore, there is a decrease in the rate of change of momentum and hence the force on the athlete. This reduces the risk of injury to the athlete. Consider two bodies of different masses initially at rest. Suppose a fixed force is applied for a certain interval of time on two bodies. The lighter body picks up greater speed than the heavier object. But at the end of the time interval, each body acquires the same momentum. Therefore, the same force for the same time causes the same change in momentum for different bodies. It shows that Force is directly proportional to change in momentum at fixed time for different bodies having different masses. Newton's third law of motion. Activity. Take a plastic boat having a small aperture opening towards the end of the boat. Blow a balloon and place the opening of the balloon on the aperture. What happens to the boat when air blows out of the balloon? And why? When air blows out of the balloon, the boat moves in the opposite direction compared to the velocity of air. The escaping air exerts force on the boat. Hence, the boat moves. Examples to illustrate Newton's third law of motion. When a bullet is fired from a gun, a force is exerted by the gun on the bullet, and therefore the bullet acquires high velocity. At the same time, the bullet also exerts an equal and opposite force on the gun, and the gun moves in the opposite direction with small velocity. Principle of conservation of momentum. Consider two objects, A and B, having masses m1 and m2 moving with initial velocities u1 and u2 respectively. The values of initial momentum are m1 u1 and m2 u2 respectively. When they collide with each other, a force F1 due to body B acts on body A. The body A accelerates. Its velocity after collision becomes v1. Hence, the momentum changes to m1 v1. According to Newton's third law of motion, body A also exerts equal and opposite force on body B, and it also suffers a change in momentum. Suppose its velocity becomes v2 and momentum changes to m2 and v2. If F2 is the force acting on body B, F2 is equal to F1. M2A2 is equal to minus M1A1. M2 into V2 minus U2 upon T is equal to minus M1 into V1 minus U1 upon T. M2 into V2 minus U2 is equal to minus M1 into V1 minus U1. M2V2 minus M2U2 is equal to minus M1V1 plus M1U1. M1V1 plus M2V2 is equal to M1U1 plus M2U2. Final momentum is equal to initial momentum. Hence, the total initial momentum is equal to total final momentum if no external force G is acting on the two bodies. This is also true for any number of interacting objects. If there is no net force acting on two interacting bodies, then their total momentum is conserved. It is the corollary of Newton's third law of motion. Momentum is always conserved in a collision. the momentum may get redistributed among the colliding bodies. One body gains momentum lost by the other. Hence, the principle can also be stated as: if two freely moving bodies collide, their total momentum after collision is the same as their total momentum before collision. The principle can be explained by an example of a bullet fired from a gun. When a bullet of mass m1 is fired from a gun of mass m2, it acquires velocity v and moves in forward direction with momentum m1v1. Its initial momentum of both gun and bullet is zero and no external force is acting on them. Total momentum is conserved. After firing the bullet, the gun moves in the backward direction. The motion is called as recoil. It moves with recoil velocity v2 such that m1v1 plus m2v2 is equal to 0. As mass of the gun is much greater than mass of the bullet, velocity of the gun is very small as compared to velocity of the bullet. So, momentum of gun and bullet are equal in magnitude and opposite in direction. Hence, there is conservation of momentum. In rocket propulsion also, the principle of conservation of momentum is followed. Summary: the total quantity of motion contained in the same body is called momentum. It is measured as the product of mass of body and its velocity. P is equal to mv. Momentum has both magnitude and direction. Its direction is the same as that of velocity. SI unit for momentum is kilogram meter per second and CGS unit is gram centimeter per second. Newton's first two laws of motion informs us about force and effects of force on the motion of objects. Newton's third law of motion describes the relationship between the forces on two interacting objects. So, that is all in this topic, student. Keep learning. Learning is fun.